So today we're going to look at the experiment 6, which is to determine the concentration of ethanoic acid in vinegar. So when you're doing this experiment, you are going to dilute the vinegar to an appropriate level so that we can use around 0.1 sodium hydroxide to standardize it. Because this naturally is very strong in our bottle, we don't want to use that strong of a concentration because we'd have to use a very strong sodium hydroxide as well, so that we can get the titration figure in around about 25 or something like that. So we're going to dilute it down. Now in the lab manual, it says to dilute it by 5 times, but when I did this with my students, I took 125 centimeters cubed and diluted that in 250. So it was a 10 times dilution factor. So when I'm writing it in here, you can decide to have either the sodium hydroxide in the conical flask, so down here in the base, which is usually where you would put the base, or you can put the diluted vinegar into the conical flask. Now this is just so we're getting a different colour change. So one will go from colourless to pink, one will go from pink to colourless. But if you're putting the if you're putting the sodium hydroxide into the burette, we wouldn't usually do that. We wouldn't usually put the base into the burette. We always put the acid into the burette. But if you're to do that, you have to make sure that you clean out the burette very well, otherwise it'll block up the tap at the end. So you can just stick to the normal one. The only difference is that one is going to go from pink to colourless, the other one will go from colourless to pink. So we're going to do this one because this is what we did. We're going to stick with the base at the bottom. So the dilution factor of vinegar was 10 because we pipetted 25 centimeters cubed into 250. So 25 goes into 250 10 times. So the dilution factor is 10. The volume of NaOH pipetted into the conical flask, that's the volume of the base. We're going to keep that as usual, 25 centimeters cubed. This is your standard solution that you're going to use, so you know the molarity of this standard solution. It's 0.1. And from this information, we can titrate this liquid, the base, against the vinegar, the diluted vinegar, to figure out the concentration of acetic acid in the vinegar. So here we have our results. I got 24 as my rough one, 23.8, 23.7, and you can see the last two are within 0.1 centimeters cubed of each other. So we're going to take these two, we're going to average them, so add them up, divide it by 2, and you're going to get 23.75 in my case for the average titer. And the indicator used was phenolphthalein. So when you're filling this in section down here, I just put in imaginary ones there. So when you're having balanced equations, you don't usually put the 1 in. This is just to bring to your attention the ratio of how acetic acid and sodium hydroxide react together. So your average titer goes in here. Mine was 23.75 centimeters cubed. Your number, the ratio that's linked with the acid, Na, is 1. The volume linked with the base is 25 centimeters cubed. We kept that as normal. The molarity of the base, you've already known from making it up yourself, which is standard solution, 0.1 molar. And the number linked with the base is from the chemical equation again, which is 1. So that's what you fill in there. And that's just going to visualize, it's just going to be easy to visualize what you need for the actual equation now, which is what we're going to use on the next page. So I've filled in here. This is volume of the acid times the molarity of the acid over the number of the acid. The volume of the base times the molarity of the base over the number of the base. So just fill them all in, put this side into your calculator first, Then we can move over 23.75, divide it in, and we'll get our acid, molarity of the acid to be 0.1 moles per litre. That, again, you have to remember, is for the diluted version of the vinegar. So to get the amount that's in the actual concentration, we need to take in our dilution factor at the very start. So here it says the molarity of the diluted vinegar. That's what we figured out in the titration. Molarity of the original vinegar. Now, if we diluted it by 10, made it 10 times weaker in concentration, we need to multiply this number by 10, because that's what it's going to be originally. It's 10 times stronger in the bottle. So take your molarity, mine was 0.1, yours could be something else, and then multiply it by 10. When I do that, I get 1 mole per litre. So the original concentration of vinegar is 1 mole per litre. The next question is to work out the concentration of original vinegar in grams per litre. So all you're going to do is convert this from moles per litre to grams per litre. So you're using your equations you always use. Number of moles equals mass over relative molecular mass. My scenario, I have the molarity to be 1, so there's 1 here. And then 60 comes from carbon, 3 hydrogens, 2 oxygens, 1 hydrogen. So 12 plus 3 plus 16 plus 16 plus 1, that gives you 60. So 1 times 60 will give me 60 grams per litre for the mass. So your value could be slightly different here. The last question then is the concentration of the original vinegar as a percentage weight per volume. Weight is going to be in grams, but the volume is actually going to be in 100 centimetres cubed, not a litre. So we're going to have to change the litre to 100 centimetres cubed. So how many 100 centimetres cubed are in 1,000, which is a litre? I'm going to say 10. So all we should do is divide this 60 by 10. And that'll give us how many grams are in 100 centimetres cubed. So it's going to be 6 grams in 100 centimetres cubed, which is 6% weight per volume.